All right, welcome back. You know we love to go deep around here. So today we're diving into something you sent our way,
Oh, yeah.
a research paper
Cool.
on
Let me guess.
Soft Actor Critic,
Uh-huh. I knew it.
an algorithm making some noise in the AI and robotics world.
Yeah, it's really cool stuff.
We'll unpack its core ideas,
Yeah,
see why it's causing a stir,
definitely.
and maybe even explore how it's being used to teach robots some new tricks,
Yeah,
like walking
how to walk.
and manipulating objects.
Yeah, it's not just theory anymore. This is like real world stuff,
Yep.
robots actually doing things.
Let's start with the basics.
Okay.
The paper mentions that Soft Actor Critic, or SAC, is trying to solve some problems that plague traditional deep reinforcement learning methods.
Right.
Can you walk us through those problems?
Absolutely. So imagine you're teaching a child to ride a bike.
Okay.
It takes time, patience,
Right.
a lot of trial and error.
Uh-huh.
Well, traditional deep reinforcement learning is kind of like that child. It requires massive amounts of data, which can be incredibly time-consuming and expensive to collect.
Uh-huh.
This is what we call sample complexity.
Okay, so lots of data, long training times.
Right.
Got it. What's the other issue?
Imagine you're trying to bake a cake,
Okay.
and the recipe has a bunch of vague instructions,
Okay.
like bake at medium heat,
Yeah.
or add a pinch of salt.
Yeah,
Getting the settings just right can be frustrating, right?
for sure.
Well, traditional deep reinforcement learning also suffers from this issue.
Interesting.
It's very sensitive to what we call hyperparameters.
Okay.
These are essentially the knobs and dials that control how the algorithm learns.
Gotcha.
Getting these settings just right can be tricky
I can imagine.
and often involves a lot of guesswork.
So traditional deep reinforcement learning methods are like a finicky recipe,
Yeah.
and SAC is here to streamline things.
Exactly.
Okay.
SAC is designed to be both more efficient and less sensitive to those tricky settings.
I like it.
And it manages this by using an approach called maximum entropy reinforcement learning.
Maximum entropy.
Uh,
Sounds a bit intimidating.
it's
Can you break that down for me?
It's simpler than it sounds.
Okay, good.
In traditional reinforcement learning, the AI agent is all about maximizing rewards.
Okay.
It's laser focused on finding that one best action to get the highest reward possible.
Right.
But in the real world,
Yeah.
things are rarely that straightforward.
There's always that unexpected pothole in the road. So
Exactly.
Right.
So SAC takes a different approach.
Okay.
Instead of just focusing on rewards,
Yeah.
it also tries to maximize entropy.
Okay.
In simple terms,
Yeah.
entropy is a measure of randomness or unpredictability. So
Sure.
by maximizing entropy, SAC encourages the AI to explore a wider range of actions,
Okay.
even if they don't lead to the biggest immediate reward.
So it's less about finding the optimal solution and more about finding a bunch of good ones, just in case things change.
Precisely. This makes the AI much more adaptable and robust.
Yeah, that makes sense.
It's like having a Swiss Army knife
Versatile.
instead of a single-purpose tool.
Exactly.
And that's especially important in robotics, where the real world is full of surprises.
So how does SAC actually pull this off? The paper mentions something about 3 key ingredients.
Right. The first is the actor-critic architecture.
Actor Critic.
Think of it as a two-person team. The actor decides what actions to take based on the current situation, while the critic evaluates those actions and provides feedback.
Okay.
They're constantly learning and improving together.
Wait, so the actor and critic are constantly arguing. Tell me more about how they work together.
It's less about arguing and more about collaboration.
Okay.
The actor is like an eager student trying different things,
Okay.
while the critic is a wise mentor offering guidance on what works well and what doesn't.
Got it.
This constant feedback loop helps them both learn and improve over time.
Okay, that makes sense. What's the second ingredient?
Remember how we talked about traditional methods being data hungry?
Yeah.
Well, SAC's second ingredient is off-policy learning,
Okay.
and it tackles this problem head-on.
Okay, I'm all ears.
Think about it this way.
Okay.
Traditional methods are like students who can only learn from their current lesson.
Okay.
They need fresh data for every single update.
Yeah.
But SAC is different.
Okay.
It's like a student who can learn from past experiences,
Okay.
even if those experiences weren't perfect.
Yeah.
It can take old data, analyze it, and extract valuable insights, making it much more data efficient.
So SAC is like the student who studies old tests and quizzes to learn from past mistakes.
Exactly.
That's smart. And the third ingredient, you guessed it,
Yeah.
it's all about that maximum entropy concept we discussed earlier.
Right.
Makes sense.
By encouraging exploration and considering a variety of options, SAC is able to discover a wider range of solutions,
Yeah.
making the AI much more adaptable and resilient to unexpected changes.
That's key.
It's like preparing for a trip by packing a variety of clothes for different weather conditions.
So SAC packs its AI suitcase full of possibilities.
Right.
But before we move on to specific applications, the paper mentioned something called automatic temperature tuning.
Oh, yeah.
What does temperature have to do with AI?
Good catch. You see, that exploration we talked about earlier needs to be carefully controlled.
Okay.
Too much exploration, and the AI might wander aimlessly.
Right.
Too little, and it might get stuck in a rut.
Makes sense.
That's where temperature comes in.
Okay, I'm intrigued.
Yeah.
How does temperature relate to this exploration thing?
Imagine temperature as a dial that controls how adventurous the AI is.
Yeah.
High temperature means more exploration, more trying out crazy things.
Yeah.
Low temperature means sticking to what seems to work, being more cautious.
Okay.
In traditional methods, finding the right temperature setting was a manual, time-consuming process.
So yet another finicky setting to worry about.
Exactly.
Right.
But here's where SAC takes things to another level. It automatically adjusts this temperature parameter based on the task's complexity and how well the AI is learning.
So it's like a self-driving car that automatically adjusts its speed based on the road conditions.
Exactly.
That's pretty impressive. So we have an algorithm that's more data efficient, less sensitive to those tricky settings, and encourages exploration for a range of solutions.
Right.
Sounds great in theory, but does it actually deliver in practice?
That's where things get really interesting.
Oh.
They put SAC at the test in a variety of simulations.
Okay.
And the results were impressive.
All right.
But more on that later.
I'm on the edge of my seat. Hold that thought. We'll be right back to find out how SAC performs when it steps out of the simulation and into the real world. All right, we're back and ready to see how Soft Actor Critic performs out in the real world.
Yeah, this is where it gets fun.
Now, you mentioned some impressive results in simulations.
Yeah.
What exactly did they throw at SAC,
Yeah.
and how did it handle things?
They tested it on various simulated control tasks, things you could think of as essential skills for robots navigating the real world, walking, running, balancing, that sort of thing.
Gotcha.
And
Yeah.
the results were pretty remarkable.
Okay, spill the beans. What kind of remarkable are we talking?
Well, SAC not only learned these tasks faster than other state-of-the-art algorithms, but it also achieved a higher level of overall performance.
Oh, exciting.
Imagine a rookie athlete going up against a seasoned pro.
Right.
That's the kind of difference we're talking about here.
Okay, that's exciting.
Right?
With simulations are one thing, the real world is a whole other ball game, right?
Right.
Did they actually test SAC on real robots?
They did.
Okay.
And this is where things get really interesting.
Okay.
They focused on two specific real-world scenarios.
Okay.
Teaching a four-legged robot to walk.
Right.
And training a robotic hand to manipulate objects.
Okay, now you've got my attention.
Yeah.
Let's start with a robot dog. Paint me a picture of the setup.
They used a small quadrupedal robot called the Minotaur.
The Minotaur. Okay.
Picture like a miniature robotic dog with 8 actuators.
8 actuators.
Which basically means it can move each of its legs independently.
Yeah, sure.
Their goal was to teach this little robot to walk effectively in the real world.
Cool.
Not just the simulation.
So, no virtual training wheels.
Nope.
Did they just plop this robot down and let it figure things out on its own?
That's what's so fascinating about this.
Yeah.
They trained the Minotaur directly in the real world.
Wow.
They developed this clever semi-automatic training pipeline where the robot would try to walk, collect data from its attempts, and then feed that data back to the SAC algorithm.
So it's like a continuous loop of learning and improvement.
Right.
But wouldn't that take forever?
You'd think so, right?
Yeah.
But incredibly, the Minotaur learned to walk in just a few hours.
Oh.
And here's where the power of SAC's robustness really comes into play.
Right.
They intentionally trained the robot on flat terrain,
Okay.
then decided to throw some curveballs its way.
Like what?
Introducing slopes, stairs,
Oh,
Even piles of wooden blocks?
you're kidding?
Nope.
Did it faceplant?
Not at all. This is the amazing part.
Yeah.
The Minotaur adapted to all these challenges without any additional training.
What?
That robust policy it had developed, thanks to Essie,
Okay.
allowed it to generalize its knowledge and navigate those new situations on the fly.
That is so cool.
It is.
So this isn't just theoretical.
It is the real deal.
It's actually producing real-world results. Now, what about the robotic hand? What were they trying to achieve there?
This is where we see Sacy's potential
Okay.
for incredibly precise control
Okay.
and fine motor skills.
Okay.
They used a 3-fingered robotic hand called the D-claw
D-claw.
and tasked it with manipulating a valve-like object.
So, like, turning it?
Yeah.
Yeah.
The challenge,
Yeah.
rotating the valve to a specific position
Why?
using only raw RGB images from a camera as input.
Hold on.
Yeah.
So the robot has to see the valve,
Right.
understand its orientation,
Right.
and then figure out how to move its fingers to manipulate it.
Exactly.
That
It's
sounds
a tough one.
like trying to solve a Rubik's Cube blindfolded.
It's incredibly complex.
Yeah.
You're essentially asking the robot to do something that requires a high level of dexterity and understanding of spatial relationships,
Right.
all while working with limited sensory input.
I'm impressed they even attempted it.
Yeah.
So how did the robot do?
It took about 20 hours of training,
Okay.
but eventually the robotic hand, guided by SAC,
Yeah.
was able to reliably rotate the valve to the desired position
Right.
using nothing but those raw camera images.
Wow. So we've gone from understanding the technical nuts and bolts of SAC to seeing it in action with a robot dog walking over obstacles and a robotic hand manipulating objects.
Yeah, it's really cool stuff.
What does this tell us about the potential of SAC?
I think it highlights the fact that SAC isn't just some abstract concept
Right.
confined to research labs.
Right.
It's an algorithm that's already making waves in the real world.
Yeah, for sure.
And the applications we've discussed today
Yeah.
are just the tip of the iceberg.
So where else could this algorithm be applied? What other problems could benefit from this sort of adaptable learning?
That's the exciting part.
Yeah.
The possibilities are vast. Imagine applying this technology to fields like healthcare.
Healthcare, huh? Healthcare, huh? That's a fascinating thought. What kind of applications are we talking about here?
Well, think about the challenges doctors face
Yeah.
when diagnosing and treating complex diseases.
Right.
There's often a lot of uncertainty involved, and finding the right treatment plan
Yeah.
can be like navigating a maze.
So you're saying SEC could help doctors find their way through that maze?
Exactly.
Yeah.
SA's ability to handle uncertainty and explore multiple options could be revolutionary in healthcare.
Interesting.
Imagine an AI-powered system
Okay.
that can analyze a patient's medical history, symptoms,
Yeah.
and genetic information.
Right.
Then suggest a range of potential treatment plans tailored to that specific individual.
That's amazing.
Yeah.
So instead of a one-size-fits-all approach,
Right.
we could have personalized treatment plans based on the patient's unique needs and responses.
Precisely. And it doesn't stop there.
Really?
Think about fields like finance,
Oh, wow.
where SAC could help manage investments and assess risks more effectively.
Okay.
Or urban planning,
Yeah.
where it could optimize traffic flow, reduce pollution,
Wow.
and improve overall city design.
The possibilities are truly vast.
They are.
It seems like any problem that involves complexity, uncertainty, and the need for adaptable solutions could potentially benefit from SAC.
Absolutely. And that's what makes this algorithm so groundbreaking.
Okay.
It's not just about solving a specific task. It's about providing a framework for AI to tackle a whole new class of problems.
So this maximum entropy thinking, it's not just for robots anymore.
Not at all. It represents a fundamental shift in how we approach AI.
Yeah.
Instead of trying to program every possible answer into the system,
Right.
we're teaching AI to learn, adapt, and explore on its own.
It's like we're moving away from rigid rule-based AI and towards something much more flexible and intelligent.
Exactly. And that brings us to an important point.
Okay.
While the research paper focused on robotic applications,
Right.
the underlying principles of SE extend far beyond that.
Okay.
It's about embracing uncertainty,
Yeah.
encouraging exploration,
Hmm.
and finding a range of good solutions that can adapt to changing circumstances.
I'm really starting to grasp the bigger picture now.
Good.
This isn't just about robots walking and manipulating objects.
Right.
It's about a whole new way of thinking about AI and its potential to impact the world.
That-
This deep dive has definitely opened my eyes to the possibilities of Soft Actor Critic.
Yeah.
It's clear that this is more than just a clever algorithm.
Yeah, it really
A
is.
paradigm shift with the potential to change the way we solve problems in all sorts of fields.
It is.
And the most exciting part is that we're just scratching the surface.
Right.
There's still so much more to discover and explore about Soft Actor Critic and its potential.
For sure.
Well, on that note, I think it's time to wrap up this deep dive.
Okay.
But before we go, let's leave our listener with something to ponder.
I like it.
If Soft Actor Critic is all about embracing uncertainty and finding multiple solutions,
Yeah.
where else could this kind of thinking be valuable? What problems in your world could benefit from a little maximum entropy approach?
That's a great question. The power of embracing a more flexible and adaptable approach to problem solving is incredible. Moving away from the idea that there's always one right answer and acknowledging that multiple paths to success exist can be truly liberating.
It's like shifting from a rigid, deterministic mindset
Right.
to a more fluid, probabilistic one.
Exactly. It's about recognizing that the world is full of uncertainty
Right.
and that the ability to adapt and explore different options is key to navigating that uncertainty successfully.
Yeah, I like that.
Whether you're a business leader making strategic decisions, a scientist conducting research, an artist exploring creative possibilities, or
Yeah.
anyone facing a complex challenge, this kind of thinking can be incredibly powerful.
So instead of getting stuck searching for the perfect solution,
Yeah.
we should focus on finding a range of good solutions that can adapt and evolve as circumstances change.
Precisely.
Yeah.
And that's the beauty of Soft Actor Critic.
Right.
It provides a framework for doing just that.
Well, listener, we hope this deep dive has given you a new perspective on AI and the power of maximum entropy thinking.
It's powerful stuff.
It's clear that Soft Actor Critic is more than just an algorithm. It's a paradigm shift that could revolutionize how we solve problems in all aspects of our lives.
Keep those questions in mind, and who knows, maybe you'll be the one to discover the next groundbreaking application of this incredible technology.
Thank you for joining us on this deep dive into Soft Actor Critic. Until next time, keep exploring.